My name is Ashlee Tyce, and I am an experienced natural resources engineer working at EA Engineering in our Rhode Island office. My educational background began in pursuit of an architectural career, but shifted to environmental engineering and science over time as I realized the need for professionals in a field as essential as water and natural resources. I earned a Master's of Environmental Engineering and Science from the Johns Hopkins University and a Bachelor's of Civil Engineering from the University of Rhode Island. Taking part in all phases of a project from conception to completion is what keeps me motivated. This is why I've enjoyed contributing to the Great Meadows Marsh Unit Restoration Project as the lead engineer. Today I'm going to speak to the multiple restoration targets for coastal habitat resiliency at the Great Meadows Marsh Unit used as the basis of design. In July 2019, a final restoration plan and environmental assessment was prepared to outline a path forward to restore natural resource injuries from the release of hazardous substances at or from the Lordship Point Gun Club site and the Raymark Industry site, both located within Stratford, Connecticut. This final RPEA addressed restoration alternatives, including the preferred alternative for the natural resources and ecological services that were injured or lost due to release of hazardous substances. The design I am speaking to today is an evolution of that preferred alternative. As an introduction, the Great Meadows Marsh Unit, or the GMMU, at the Stuart B. McKinney National Wildlife Refuge, is located within the Long Island Sound watershed along the Connecticut coastline. The GMMU is comprised of intertidal channels, tidal salt marsh, filled wetlands and upland, barrier beach, and the Lewis Scott embayment. The GMMU contains the largest block of unditched salt marsh remaining in the state of Connecticut. This 600-plus acre marsh upland complex is a remnant of what was once an extensive tidal marsh system covering 2+ square miles. Today, the GMMU area is predominantly salt marsh habitat that has been previously disturbed by the historic placement of earthen berms and dredged soils and filling of wetlands in the late 1950s. As a result, many areas with high elevations exist that no longer function as wetland habitat, while many areas of low-lying marsh have poor to very poor drainage, which negatively impacts the viability of marsh plant communities and the functioning of marsh habitat. The project as designed improves approximately 54 acres and consists of many work components that aim to meet many different restoration targets. It is these restoration targets that I am going to speak to in this presentation, rather than many other interesting aspects of the design, such as data collection. The work components of the project are shown here and generally broken up into the following subcategories. Shrub and forest enhancement will be achieved through removal of an invasive understory and planting of native salt-tolerant shrubs and appropriate herbaceous plants. The vegetated buffer is a 20-foot wide swath of land that will be established around the larger freshwater pond through invasive species removal and the installation of salt-tolerant plants and seeding. Existing transitional habitat consisting of existing trees and shrubs benefiting passerine bird species will not be regraded. Marsh pink and terrapin nesting habitat is proposed within the pink outlined area. The contractor will remove invasive plants, regrade, and hand install marsh pink seedlings while protecting existing marsh pink plants. Open sandy soils will be placed for turtle nesting habitat. Intertidal flat and salt marsh restoration will be achieved by breaching an existing berm and constructing an intertidal creek channel to connect the smaller freshwater pond with an existing nearby salt marsh channel. Regularly flooded and irregularly flooded marsh restoration is the largest restoration area, where positive drainage ranging from 6 to 3 feet NAVD 88 will be established in the transition from irregularly flooded to regularly flooded marsh. Hummocks creation will serve as future salt marsh bird nest sites. The excavation of tidal channels will be performed throughout the site to restore or create salt marsh and provide normal tidal exchange and wetting and drying. Culvert removal will take place to restore normal tidal exchange, and areas to receive thin layer deposition are shown in blue. The overall goal of the project is to restore healthy salt marsh and other coastal ecological communities and habitats. considering projected sea level rise and natural resource resiliency and sustainability. Secondary project goals are to improve public access and safety and increased resiliency to the town of Stratford. In an effort to help ensure restoration success in these areas, the project was designed such that the final elevations of both regularly flooded and irregularly flooded marsh communities are targeted on the higher end of today's viable elevation range for these habitats. This design measure will allow for greater resiliency and response to predicted sea level rise. Through a variety of existing data review and desktop and field techniques, healthy, regularly flooded marsh, or low marsh, was identified at elevations below 4 feet NAVD 88, predominantly covered by Spartina alterniflora. Healthy, irregularly flooded marsh, or high marsh, was identified at between elevations 4 and 6 NAVD 88, predominantly covered by Spartina patents, and elevations above 6 feet NAVD 88 were determined to be beneficial to transitional habitat for passerine birds and future salt marsh migration. Several threatened and endangered species were the focus of habitat restoration efforts, including the Connecticut species of special concern, the salt marsh sparrow, the state endangered marsh pink, and the state endangered diamondback terrapin. Protective measures for additional plant and bird species of concern have also been incorporated into the construction design, such as construction buffer fencing. Just a few of the multitude of examples of how the design for the GMMU was molded by the needs of these special species of concern include the construction of hummocks by hand to peak elevations 6 to 12 inches higher than existing nesting sites to combat sea level rise in areas in the vicinity of mapped existing bird nests, the siting of habitat expansion for marsh pink in areas of low salinity with freshwater inputs, the existing elevation of marsh pink between the elevations of 5 and 5.5 feet NAVD 88, and the plant's need for as little habitat competition as possible. And for the expansion of diamondback terrapin habitat, sandy soils at elevations approximating 7 feet NAVD 88 have been proposed. Time of year restrictions for each of these species have also played a part in construction sequencing. Non-native species are a serious concern at the GMMU. One prime example of non-native invasive species rendering habitat unusable for certain species at the GMMU is the colonization of diamondback terrapin nesting areas by autumn olive, which establishes and thrives on loose, poor, sandy soils. Common reed presents one of the greatest threats to endangered marsh pink, which requires open space and cannot compete with this tall, invasive grass. Prior to construction, the trustees may choose to implement components of the Stuart B. McKinney National Wildlife Plan Refuge Spatial Fire Management Plan. During construction of the contractor will mechanically remove invasive species and it will be trucked to a certified disposal facility. In areas dominated by common reed, excavated soils to a depth between 8 and 10 inches will not be reused for regrading and fill elsewhere on site as to limit the spread of this invasive plant's rhizomes. Within marsh pink and bird nest location buffer zones, the cutting of common reed and the application of an herbicide to cut stems will be performed by hand. The existing viewing platforms will no longer be accessible once 2 defunct culverts are removed from site to improve tidal exchange. Therefore, the existing viewing platforms will be replaced with 2 better-sited viewing platforms to enhance the visitor experience. Resting, feeding, and nesting habitat for passerine birds is a component of this project, and shrub species have been selected for the foraging and habitat potential. Passerine bird species have a predilection for berry-producing perennials. During construction, a significant amount of sediment will be excavated to varying depths from the proposed wetland areas to establish the desired hydrologic regime. Suitable excavated material will be reused on site where proposed grades require fill rather than transported and disposed of off-site. Site-wide, approximately 43,300 cubic yards of material will be excavated or cut, and 14,000 will be placed as fill. This is a total net cut of 29,300 cubic yards of material that will have to be reused off-site or properly disposed of. To minimize the amount of soil being trucked off-site and to increase the amount of healthy marsh restored, areas of thin layer placement have been maximized. The reuse of excavated soils across the site heighten the importance of construction sequencing. In addition to the sheer volume of soil being moved across the site, Another unique soil management aspect of the project was identified through test pits conducted by NRCS. Sulfurous soil conditions were noted through olfactory and soil color observations. These observations translate into the potential for excavated soils from these locations to develop into acid sulfate soils if reused elsewhere, a condition that inhibits normal plant establishment and growth. Therefore, the contractor will be required to test the pH of soils excavated from locations at risk of developing into acid sulfate soils prior to relocation. At the beginning of this presentation, I listed the categorized work components of the project as a whole. This figure demonstrates those varying restoration projects in terms of proposed vegetated cover and elevation. Transitional habitat is shown in orange and occurs at elevations of 6 feet NAVD8 or greater. Phragmites is shown in orange. Phragmites-dominated irregularly flooded marsh is shown in light brown in existing conditions and will be eliminated in proposed conditions. Irregularly flooded marsh occurs between 4 and 6 feet NAVD88 and is shown in yellow. Regularly flooded marsh, shown in green, occurs below 4 feet NAVD88, and the conversion of the smaller pond from freshwater to saltwater is demonstrated in proposed conditions. The Long Island Sound Tidal Wetland Restoration Session contributors would like to thank you for listening to our presentations and encourage you to reach out if you have any questions or if you would like to further discuss the material. We hope you enjoy the remainder of the virtual Ray 2020 Summit. Thanks and goodbye.